Share screen. Try this left-handed. All right, so last time we talked about the basics, as it were, just the base, the crank, and the cam. At least to give you a general idea of where we're going. I can't remember if in this class we talked about some more advanced options. It was mostly just these are the basics of making a cam toy. There are a ton of real world examples, meaning like people made stuff actually tangibly, for real, and that you can just go ahead and copy. It's fine. It's not plagiarism. These are technical challenges, not, original works of art. And the ones in real life are not, they're much more impressive than just a basic up down, although this does technically satisfy the requirements. It's not that much harder to have extra cams in there that make the lifting happen in a different way. The key is everything's working off a single crank. Spinning ones are a lot more common in the wooden world, just because it's a lot easier to make happen. But you could do it in Inventor if you want to. Also, same thing. Any one of these ideas are one of the ones that I showed you. Especially once you get the basics of how to make the parts and how to constrain them so that they actually work, you can change yours. And like I said, once you know how to do this, even advanced ones are super, super easy to do. This guy has some like workout ones.
Various activities in the fitness center. One by one, real quick. This one is activated by a single touch only here at the tip of the sword. This is a pull-up guy.
He's using so the hard part in Inventor is making constraints to look normal and to still act. This is not a bad format for how it is the trickiest part, the part where the cam connects to whatever's going up and down. I've had to use, depending on the shape of the cam, different shapes. Like this one is just you can see it's just a curved hemisphere, or not even a hemisphere, a cylinder. These rollers tend to work well. It's an extra part file, but it's the issue is the constraint. It's not a mate constraint. It's what's called a transitional constraint, because you're connecting the face of the roller to several faces. Even though in real life you would think the edge of the cam is smooth, it's actually, you can see there's a line there. This face right here is one face, this side is another face. Anytime there's a line that's an edge, and Inventor gets tricked up sometimes. This one, and the more complex the shape of the cam, the more issues that you would have. Let's see if this one, let's delete this one, see if it works. Yeah, okay, the more complex, turn off the visibility on the base, the more, oh, that's not what I want. Give me a second here, let's try that. The more complex the shape of the cam, the more of a hassle Inventor is going to be to deal with it. But this hemisphere shape does travel well on more complex shapes, more complex cam shapes. And what's the other one? This one is probably the most complex cam, even though it's just doing the same motion. Let's see, it's probably connected to the base. Maybe it's the origin. Let's try this one. Yeah, okay, so because the cam or the lifter actually like comes down sharply like that, it gives Inventor a lot of trouble as far as following that edge, which is the whole point. It's a follower. If you do want something that has this sort of shape, that in shape, the way that I would do it is start by making a new, well, obviously start by a new part. It's a part. You need it be. Whatever dimensions you're working with, I think we have like 3/8 was the size of the crankshaft. Then you have whatever shaped ellipse so that you can keep the like the main shape, and then get a line tool to like either maybe something like this, and then trim the outside here. Okay, extrude this, whatever it's supposed to be. Okay, and you can see as this spun around, what how the lifter would follow that inside edge. I think if you're going to do something where it's like this, make sure you don't have it go sort of past 90 degrees. I don't think the lifter would like it to sort of go sort of in before it goes out. But I think straight up and down is probably okay, especially if you use the sort of roller type. Okay, let's just go through like the basic one, wherever we were, which was, please don't break this. Nope, it's not that one. It was this. No, was it this one? Did we have 2 cranks on it yet? No, it was this one, P1. There we go. Uh-oh, that's not a good sign. We had a cam on it, didn't we? Cam. Yeah, there we go. All right, so the base is like that, and can't remember which class we did it in. Guys, can you just hang out for a second? I appreciate the enthusiasm, but there's wisdom to be gained here. So the extrusion, for the most part, I will always just do, for a basic thing, it doesn't matter the direction that you extrude, but can you just hang out for a second? Like normally I do extrusion, I just do X forward, but the thing is, the better way to do things is really to do it symmetrically, meaning half forward, half backwards. And what that means is we will automatically get a plane to work with that goes right down the middle, which in this case is the XY plane. And so if we do that, when we go to place it, then we can, well, first we'll do like for real, just hang out like another like 2 minutes. It's all right. Like I said, I appreciate the enthusiasm. You can do a mate of the axis of the hole you want it to line up with the cam's origin, its origin. And if you have 0 offset, it will line up exactly. Okay, so that's just a little shortcut for all of that. Okay, for this, I still need to do the angle constraint of one of the cam's angles, the first type of angle constraint, to one of the cranks. One of the crank's origins. One of the ones that goes that way, and also 0. I think that's it. And yeah, okay. So the lifter, I'll just do a simple lifter for this one. Make a new part. And let's go with how big was let's measure, this is 0.5 in diameter. So we'll start with our circle. And let's, I don't know, 8, doesn't matter, 8 inch, I guess. And the simple shape for the connecting part is just a semicircle. So let's put a sketch on one of the perpendicular planes. And how can we do this? Let's go. What's the best way to do this? Maybe a circle from here. And a line that goes across the middle. And trim the other part. Let's see if it lets me extrude this. Good. And we need to extrude it. Well, first, let's finish sketch and extrude. We definitely want to extrude this in both directions, and maybe just 0.5 will make it the right size. And I don't know, put a design on the top. How about Christmas tree? Who cares? Something like this. And we'll do a revolve. Just, I don't know if it's even going to look like anything. And so let's save this. Let's call it cam lifter P1. And how about, I don't want to spend too much time on design stuff, but let's see here. Okay, so we'll place cam lifter P1. First thing we have to do is constrain it to the hole there. And so we're going to mate that axis to this axis. And if it goes the wrong way, you can usually guess switch it and that'll be fine. And portions are all out of whack. I actually need to, it's not going to fit. Let's open up this part file. I already have it open, but let's make it a little bit smaller. Right click, edit sketch. And just making a small change like this shouldn't break it, I don't think. If it will break if I do that. If this crosses over, it will definitely break. Let's see if that doesn't break it. And we'll save it. We'll go back to the assembly. There we go. It's a little smaller. All right. And I need this to be facing the right direction, but it's not a mate constraint. I can't mate those together. It won't, because it won't connect. I need an angle constraint. Let's do angle. We'll turn off auto project or auto predict like that. 0 degrees. Good. So now it's locked in there. I can tell if I grab this and go back and forth, it doesn't spin, which is what we're looking for. And it should line up perfectly. It does. And the constraint that makes it happen is a translational constraint. I said transition, but and the two selections are this face and then that face. Hit OK, and then it should follow it. It may break if you move it too fast. Like sometimes it'll pop through the other side. It's not doing that this time. That's good. But that's the basis or the basics for making it work. All right. So once you can figure that out, you will not have too much trouble figuring out how to do more complex things.
Here we have an offset cam. We've got a pin over here at the side.
Even though this one doesn't use, it does it's the same basic idea. If you want to do something more complex than what I've shown you, and even if it doesn't use technically a cam, we're still, this category of device is called an automata. And that's basically what we're working on. I don't know. You can find a ton of these videos out there. All right. So if you have any questions, let me know. I'll post this as soon as it finishes processing. All right. Good luck.